before it will become massive and before decentralized backend solutions will grab substantial share. But I'm totally confident they will. And they'll be a significant part, not 1%, not 3%, but significant percentage of IT solutions will be on backend. So again, you guys are in the right place and at the right time to benefit from that adoption. How can I exchange Freeton and get cash? There are a few listings. There are 5 or 6 listings of Freeton. It's not my domain, so I'm not following that deeply. There are a lot of peer-to-peer and quite famous exchanges like HitBTC, Bitcoin.com. I know some of the bigger ones are considering listing, some of the big global exchanges. There are a few peer-to-peer exchange platforms. And there is actually partners that we have called Merkle Tree Capital, who has 4 exchanges or wallets in Africa. And I don't know on the timing, but I'm pretty sure that in February they will do the listing. So there is even African platforms. But again, if you just Google, if you go to CoinMarketCap or CoinGecko and see what exchanges support Freeton, you'll see all of them. I think I answered the questions in the chat. Happy to answer more questions or people from the Zoom. Unless Coyote, it's time to move on.
All right, thank you very much. I think
it's my pleasure.
Yeah, thank you very much. I think if you have more other questions, we can be able to direct them down to you. Probably now, I guess you're on the Discord channel. They could be able to send you some messages there as well, and they can also message you on the Telegram group page as well. So in case they have any.
Sure. If you join Freeton Africa chat and Telegram, I'm in there. Please tag me directly. I'm there as Alexander Filatov. So Freeton Africa, if you search in Telegram. Okay. Thank you very much. It's a pleasure. Thank you.
Yes. So right about now, I'd like to welcome, I can't pronounce his name, but Abhishek. I don't know.
Yes. Abhishek Bhattacharya, but Abhishek is good. I think that's enough. Thanks,
okay,
Mr. Kavade.
Thank you very much. So Abhishek is a blockchain expert and professional. He has been in the space for a longer time. Especially on the curriculum that I shared with you earlier on what is blockchain, this and some other important component as well for we to have a background knowledge on what it is you are doing. Then it's going to be followed by the developer team from the Freeton, the hackathon program starting tomorrow. So, Mr. Abhishek, it's over to you, and we can start.
It's a pleasure to be here, to be speaking to this audience today. And I could see the hackathon going up, had started, and I wish everyone all the best. And I believe that what we are going to learn today is going to be exciting for you all. Pretty much the lecture is about the core of blockchain core concepts. And by the end of it, by the next 1.5 hours, I believe that you should be able to understand blockchain at a much better level because we are going to target such topics. And we are also going to take a look at certain use cases from across the world which have happened on blockchain using blockchain technology, and they have real customers and are also working with one is also working with government, which is my own use case, and government of India, of course. So I hope that this would also give you an idea of what exactly to do when you're planning for this hackathon as well, or even after that, if you're going into blockchain, this is going to be very, very valuable, I believe. So give me 1 minute and allow me to share the screen, please. Yes, I think, yeah, please, Mr. Kavade, could you please confirm once you're able to see my screen?
Yes, we can see your screen.
Perfect, and I hope it is changing as well. Great. All right. Thank you so much. So much so that I let me just place my Zoom window in a manner so that I can view the chats. So if you have any questions, any doubts, please do reach out in the chat, and I'll make sure that I answer them. And yes, perfect. All right. Welcome everyone to this lecture. It is a pleasure to be giving this lecture out with in conjunction with Africa Blockchain Institute for the Campus Blockchain Hackathon, and we, as you can see, are entrusted by so many good partners. This, yeah, I hope the slide changed for you as well. So this today, what we plan on covering is basically the core of blockchain technology. We are a bit pressed for time. We are starting a bit late. But however, we are going to make sure that as much as the core concepts we can cover, and we might move a bit fast. But in any case, in any time, if you believe that I'm speaking very fast, or I'm moving at a big speed, please do unmute and let me know, Mr. Coyote, if you see any specific chat from regarding the speed of the lecture. Please do let me know. Then I'll immediately make sure that I reduce it. Perfect. So as a roundup of what we are going to learn today, first of all, we'll take a look at an introduction basically to overall decentralization, DLT kind of technologies, and particularly to blockchain, how blockchain came into effect, why it was needed, why were people looking for decentralization. That is something we're going to take a look at. We will take a close look at the types of blockchain that we have. This may sound like a very easy topic, but when we are differentiating between public, private, and consortium blockchains, it becomes very important for us to understand that what kind of blockchain to choose based on the kind of use case that we are trying to develop. That is important. Public blockchains, we all know, Bitcoin, Ethereum, we all want to work on them. But then again, the entire world in real life, when we are building real world situations, use cases, we are not 90% of the times it would happen that a public blockchain would not be very beneficial or not be the choice that you would want to take up. So that is important. Apart from that, we have so we'll continue with basic of public blockchains. We'll just take a look at an overview concepts of nodes, network, incentive mechanisms. We'll try to understand what kind of incentive mechanisms are usually there, but we won't go very deep into this, not technical, but definitely why these exist, and what kind of incentive do they provide majorly. And also I've made sure that we also take a look at two, if you're looking at two types of incentive mechanisms, we also take a look at two kind of attacks that nodes can commit against these incentive mechanisms. At the end, towards the end, we will take a look at three use cases I have prepared. Those three, very short, not long, we won't discuss at a lot of detail, but those three use cases, again, as I said, are real world implementations, and I believe that is what will, please stay put, that is what will help you understand that what exactly to build when you are planning to use blockchain technology to build something. Perfect. All right, so that is what my purpose is for the next 1.5 hours. We have all of that. And I hope that this lecture actually pushes you to the front of the understanding that's needed to loop up to win those tons up for grabs in this hackathon, right? It would be lovely to see that happen. As a basic introduction to set the stage of why I might be a good person to even talk to you about blockchain. I am the co-founder of a startup called World. We are into we are an agri fintech blockchain, and we are India's largest such platform on blockchain, and also the first on blockchain. And we are working with the Indian state governments. So that gives me to talk about a great use case today, where you can see that India has been very much dicey about the future of cryptocurrencies. But then again, we are talking about blockchain use cases, and India or any such government has definitely invited it with open arms. So that is one thing we can take a look at. I have experience with. Apart from that, I was previously at a company called PolicyBazaar.com, which is an Indian unicorn insurance aggregator. Have experience in that as well. I'm an author and a speaker. Regularly do that. Have authored 2 books, and 2 are coming up with Springer just in 2021. And Apart from that, I have similar lectures I've given to more than 4,000 faculty and PhDs and students just in 2020 itself. So this is a passion that I follow. So I hope that you'll be able to see that passion. I'll be able to impart that knowledge across in these 1.5 hours. Perfect. That was a brief intro. Excuse me. So let's take a look at what today's basically the entire session looks like. We'll take a look at why blockchain, we'll understand the concepts, I've already told you that, and also why decentralization was essential. We'll learn about consensus mechanisms as well, in addition to what I said earlier, and use cases. I think this is something I've already covered. And ultimately this lecture is not going to be very technical. If I have any questions, if I see any questions in the chat which require me to go technical and we still have time, that is something I would really love to go a bit technical as well. Otherwise, this lecture is going to enables you to move past the barrier of entering blockchain concepts, and then you can take up more advanced courses or more advanced studies in the same segment. Great. Let's start with the topics then. So as I have planned this lecture, we are going to first set the stage by understanding why was this everything needed. It has been what, a decade or 11 years since when Bitcoin really made blockchain technology very popular. That was not the first time that blockchain saw an implementation. It was back in 90s when the technology behind blockchain came into existence, and it is evident in papers written by Dr. Scott Stornetta, who is regarded as a father of the blockchain. So it is since then, but it is almost 10 years, 11 years that Bitcoin came, since 2009. And in the recent past, 3 years, 3.5, 4 years, you have seen the Bitcoin go crazy. And with that, blockchain's implementation and use of blockchain technology across various sectors, this has created a lot of hype. So we will first take a look at why did this even come into being, the need for decentralization, right? So let's start the example. Let's start the discussion with an example of a bank. So currently, so what is decentralization? I'm sure that if you've been into blockchain, then some of you might be having an idea of why this came into being. But for the people who are not very much into this, I would be glad to start here. So let us say that I use any particular bank. You have a bank account. I have a bank account. Even if we are in the same country or abroad, maybe we use SWIFT mechanism to transfer money. In any case, if I send you say $100. My bank would write it in its own ledger, which is centralized, by the way. It will write in its own ledger that Abhishek gave $100 to Mr. Coyote. What happens is that so this is updated by my bank. This is updated by Mr. Coyote's bank as well. In case we both have the same bank, then it is the only one bank that is writing it in their ledger. That's fine. That is how it has been happening since decades now, since forever, since when banking systems have existed, right? But what happens if the bank, what the bank does is essentially, tomorrow morning you wake up and your bank, which you trust so much. So trust is the keyword. Please make sure that you remember this. Trust is the keyword around which all of this is centered. So you trust your bank so much, but tomorrow morning you wake up and you see that your account does not reflect, my account does not reflect the $100 that I sent to Mr. Coyote. What happened is that my bank overnight decided to collude, say with Mr. Coyote or say with Mr. Coyote's bank, and remove the ledger that there was any transaction that ever happened regarding the $100, right? So that's basically where trust becomes an important factor. You cannot do anything about that because that was the only ledger where this $100 transaction was written. When that happens, I have no other way than to believe that I have lost those $100. But the problem is that I had to lay trust in a system which is centralized in nature. That is what centralization is, and anything that opposes this particular system is what decentralization is. That's essentially all of it. So to be honest, this is why. So currently, many people I've taught this, they come with the example that they come with the doubt that yeah, but we have so good banks in the world, and then we have so good companies such as Google or Facebook or maybe banks like JP Morgan and so on. They will never do this thing, right? They will never go bad. They will never go rogue. But that is the whole problem. What if they do? What people do not understand, the people who do not understand that someday something like this can happen, they are the ones who are not going for decentralization. To understand decentralization, you have to understand that what you are trusting today can be nowhere to be seen tomorrow morning when you wake up. That is the whole problem. And if you're talking about great brands, they might never falsify information. What about everything else that you trust in? It is not just big banks that you trust in. You trust your data in the hands of many such companies, even small startups, right? So for example, we are a 2-year-old startup, even though we are India's largest such blockchain network, but we are just 2 years old. But if they place a trust on us, and tomorrow we just want to go bad, and anything can happen, right? The founders decide that okay, let's delete the user data that we have. What happens then? That is the whole point of decentralization, and that is why we ourselves are a blockchain company. And every partner that we have banks as partners, we have governments as partners. We make sure that the entire network runs in a very decentralized fashion, so that tomorrow it does not happen that my startup went bad and the entire economy fell. That is what the example is. That is why decentralization is needed. I believe that gives you a good understanding of why decentralization was needed. It might look like not a big issue today, but just think about all the organizations and all the people and all the companies that you lay your data in the hands of. Any one of them can go rogue tomorrow, and that is where the problem would occur. So just to go over them, the grave issues of a centralized world, you do not have the control over your data. That is the point. You have to have control over your own data. That is what decentralization really fosters. Also, as we just discussed, you cannot trust a single entity, however big they are, because many a times even big entities commit such frauds which no one is aware of, and everyone is at a loss at the end of the day. And these frauds are uncovered years later. So just imagine how many people, how many businesses, how many partners, how many governments, all of them lost money to the fraud over all those years. And when it is finally discovered, there is nothing you can do. Right? I see someone unmute. Is there a question, or am I going fast? Anything? Mr. Coyote, is it all fine? Is the voice good?
Yeah, it is good. Please go on. It's going fine.
Perfect. Thank you so much. All right. I have the chat open. If you have anyone, please write to me. And also, just continuing quickly. Yes, Claire. You have a question? Oh, I think by mistake you may have. Okay, perfect. So again, going ahead quickly. So one very important point. Make sure that if you're jumping into the use cases of blockchain, make sure that you are implementing blockchain solutions in an implementation where these kinds of problems are there, such as collusion between two companies, corruption, frauds, scams, scandals. All of these things either of these things are happening in that particular segment. That is where you'll face the most benefit. If you're just sharing maybe social network content and you want to put that on blockchain, or you want to make it decentralized, there is not a lot of use case that might be covering there, unless you have such use case which you can define, which I might not know. But if there is some, especially that is why financial platforms, fintech platforms in India, abroad, everywhere I've seen, in Africa as well, in US, everywhere I've seen that fintech platforms have been the ones who have benefited the most from these concepts. So hence, because they face most collusion, frauds, corruption, scandals, all of that. So make sure that you have a very direct use case where decentralization can help. Otherwise, it might be a wastage of efforts. We'll see that very soon. So as we were discussing, so is the answer to all of this a blockchain, any DLT technology, right? We'll take a look at that. So that is the question that we pose, and that is a question that the blockchain industry has been trying to answer since about the last quite a few years, right? This is the question that we are trying to answer. So before I go to one core concept of blockchain, and to take a look at what public blockchains look like, and what are the types of blockchain, I would love to share a couple of myths that the world has till currently regarding blockchain technologies, right? So I see a chat. Uh, Okay, so hi Lawson. I see that. Can we have the document of your presentation in French? Because I'm a francophone, so it's good to see that you're joining. You're French. I'm sorry, I am not French, but I don't know if Mr. Coyote would, or Africa Blockchain Institute would be able to provide that. But let's see. We'll have a talk maybe later, maybe on WhatsApp or email. I'm not sure. Spanish is something that I know, so that would have helped. I could have tried, but not French. Not good at French. All right. So perfect. So let's go ahead and take a look at the two myths that I wanted to share quickly. First of all, everyone, believe me, when I say everyone, I am talking about even faculty and PhDs of great institutes, India and abroad, people from Bulgaria, New Zealand, United States, Australia. These are all the countries where I've taught people. Everyone, when I say, is that believes that cryptocurrency and blockchain are one and the same thing. There are such a great number of people that I know who believe that blockchain and cryptocurrency are one and the same thing, and that is the case. That is why I usually give these slides before that is why I usually give these slides, this particular slide, before I start with any real content, any deep tech content. Blockchain is not cryptocurrency. Cryptocurrency is one use case of blockchain. If you're talking about Bitcoin, if you're talking about Ethereum, Ether is again a good use case of blockchain. It has a great platform for smart contracts, but it is also a currency. The currency is an implementation of blockchain technology. It's not the whole of it. So we have to make sure that we understand this part. So going ahead, that blockchain is not all about crypto. That is why so many governments who have banned cryptocurrencies are very much in it for the blockchain technology. They are very much attracted to the characteristics of blockchain technology, and they want to implement blockchain technology even in the public domain systems. So make sure you know that. Second one is that blockchain can become everything. A lot of people. So these myths I have not taken from the internet, believe me. These myths I have, you can say I have understood that what kind of myths my students actually had, and 4,000, 5,000 of them just in 1 year. And that too just in the COVID months of 10, 11 months, right? And these are the myths that I came up with because I saw that everyone is having these kinds of doubts in their mind. So blockchain can become everything is what people think. People believe that if they have a blockchain network, whatever data they are getting from the blockchain network back, that is going to be truthful, right? And they believe that every use case can be fulfilled by blockchain. So for example, someone who wanted to build a to-do app, I have listed here, I've written it here, you can see on the screen that someone wanted to build a to-do app, and he came to me and said, I want to build a to-do app on the blockchain. But why? If apart from learning, if that is something you're trying to do to learn Solidity, to learn smart contracts, to learn blockchain technologies, best case. If you want to make a business out of this idea, why would you want to put a to-do app, a to-do functionality, a to-do list on blockchain? Blockchain has very specific characteristics. I think I should have put a slide on that. I'm sorry if I missed. Blockchain has characteristics of being the data being immutable. Whichever it goes on blockchain, it is immutable. You cannot touch it. You cannot change it. Blockchain gives you the characteristic of finality, of provenance. These are very deep technical words, but the blockchain is able to give you. It is able to tell you where finality is where the data is heading. What is the actual data? Provenance tells you that where the data originated. What is the entire shape of the data? How did the data come into existence? Who uploaded? Because you know that none of it changed, right? So immutability is that one characteristic which helps. Security is again a characteristic of blockchain networks. So all of these characteristics you have to map out, which I said I think 3-4 slides back. You have to map out your characteristics with blockchain, with your use cases that you need to solve. If your application or your web app or Android app or anything does not need blockchain's characteristics, I do not believe that you need to implement blockchain there. Just go ahead with a database. Just go ahead with an RDBMS system, relational database. Because if you don't do that, then blockchain is going to be an overhead, because blockchain is not very easy to use. We all know that for sure. The concepts are pretty different. They're easy. Well, now once I know blockchain concepts, it's so easy for me to teach it to people, and then people who understand, they take it in happily, right? But when you're new to blockchain, it becomes a bit of a complex behavior, complex nature of these concepts. And implementation of these concepts becomes more and so difficult in your everyday apps, when you're building an Android app or a web app especially, because then you have to do a MetaMask integration. You have to make the customer's browser talk to your network, which is running on the blockchain. So all of this is a bit complicated, and eventually what happens is people don't use your product. So this will be an overhead. So make sure that your use cases are very much mapped. Please do not build a to-do app on blockchain and make it a business. Because you're not going to create a fraud on a to-do app, right? You're not going to scam people in a to-do app. You're not going to you don't need the data to not edit in future, right? So these things you have to make sure. We are using blockchain to provide loans to farmers in our country. Never believed that a segment like farmers would be using a blockchain system. And it's quite possible that our farmer customers don't even know that what the loan they are getting on is a blockchain technology. Many people in my country have not used blockchain technology yet, but our farmers have used blockchain technology. So that is something that is one use case that is getting a lot of attraction in India itself, right? So, but then again, it's because our blockchain solves the fraud problem in loans. It's just not there to be on the blockchain and ride the hype game. It is there to solve a particular problem. That is one point I wanted to share. So that is another myth. Please don't think that blockchain can be implemented everywhere, right? Okay, going ahead, I see another chat. Let me take a look. Hi Abhishek, where we get this presentation document? Hi Santigi, I hope I pronounced your name correctly. I will be very happy to share this presentation on maybe WhatsApp or email with Mr. Kayode or you guys, or you can even reach out to me and take this presentation. Either way works. I'm happy to give out any content that I have along with the knowledge that I'm trying to give in this lecture, right? Perfect. Claire has asked one question. So one request, Claire Lawson, one request that if you just don't direct message me, rather if you send it to everyone, what will happen is that everyone would get to know that what is it that I am answering, and people would have more idea. So Claire has asked that what are the core characteristics of blockchain? So as I just said, I'll quickly go through it once again. I'll just quickly go through it once again. The core concepts of blockchain are these only. It protects the data from being manipulated. It does not allow the blockchain systems, once a data goes on a blockchain network, we will take a look. I have a couple of slides of how the blockchain works essentially, and we'll take a look that how the behavior is. And apart from that, it is, as I said, it provides finality, it provides provenance. Again, I'll just repeat in a sentence. Finality is what the final shape of the blockchain data is. Provenance shows the history of that particular piece of data. You can go further and read about it. Blockchain provides provenance of data, shows you where the data came from, what the data looked like, and that the data did not change. Security is something that blockchain provides. Another core characteristic is transparency, big one. Nothing is as transparent as a blockchain network. You know that every transaction on the Ethereum blockchain platform, you can take a look and you can see. Anonymous, big factor. Things are transparent, but they are anonymous. That is the best part of blockchain, because you are essentially, if you're doing a transaction, you're essentially behind a 30 or 40 character address, 40 character long address. What happens is that people know which two addresses did a transaction, but they have no idea who were the two people in real life behind those public keys or behind those addresses. Trying to keep it non-technical, but these are the encrypted addresses, wallet addresses that you get, which I guess many of you must have already tried out till now. Create a wallet, do a transaction, and so on, right? If time persists, I would be happy to make it live, go on a blockchain explorer and show you a couple of blocks how it's made, right? All right, I'll quickly go ahead. Yes. Okay, so we have dealt with the myths. We have taken it out of the way. I would really request all, I see 20 people here. I would request all of you to make sure that you keep these myths in your mind. Not cryptocurrency and not everything, right? Blockchain cannot be both these things, right? So out of everything, why blockchain? Here is where we take a look at. So in addition, Claire, to what I just explained, this is the slide I was talking about, where we take a look at how blockchain has the kinds of characteristics that we were discussing. So now I'll quickly go through this because mostly I have explained it. First of all, a blockchain or a decentralized network has no central point of failure. What is a central point of failure? Just like what we discussed at the beginning. JP Morgan Bank taking care of my entire transaction ledger, it goes rogue, it goes down, its systems get hit, eventually I lose access to my money, I lose access to my transactions, right? So that is what does not happen in a central point of failure, right? So blockchain has many nodes, multiple nodes in a blockchain network, which eventually make sure that the data is in a very distributed nature. Hence, if any of the nodes go down for any reason, what happens is that other nodes can serve up the same kind of information, just like distributed systems in general. And on the other hand, if one node goes bad, one node goes malign, they want to do something bad, what happens is that other nodes make sure that things are in place, and they can recognize that this is the particular node whose ledger does not match, and that something bad has been done by that particular node. So that is what central point of failure means. Trust. Please note this sentence very carefully. This is real from real experience, not from Google. Trust comes before technology in business. You believe that businesses are running on the technological platform that we are providing. We do that as well. When we are doing loans for farmers, we have an entire suite of platforms we have given to banks, warehouses, quality managers, farmers, traders. Everyone has a platform. But ultimately, what comes into effect, what comes as a use is the trust that we've been able to build. However, because trust comes before technology in business, the need of centralization to trust that particular party has been there since forever. If that is something that blockchain systems can replace, that is where actual real life industrial use cases are found, just like ours. These we are talking about Indian banks. They have been very secure in their nature. They have been very strict about their methods. But even they are accepting a blockchain network like ours because of the kind of trust we are able to build on a decentralized network. It's not just the trust in us, because we are again a centralized entity, a 2-year-old startup which can maybe shut down tomorrow, which can go bad tomorrow, do something bad tomorrow. But then again, the platform and the technology that we've built, that is completely on blockchain. It's decentralized, and when we are selling it to the banks, we make them understand that you're not buying us, you're not buying trust from us, you're buying trust in that decentralized, trustless system. Effectively, that is what comes here. So trust comes before technology in business. Again, as I said, immutable and hack proof. See, scam and scandals always happen, and your money and data and transactions and everything just goes poof. It's all over for you, as we discussed in an initial example. In the case of blockchain, that never happens. In fact, it is one of the strongest technologies that we know exists. Also, when we will be taking, just in a couple of slides, as I can see, we'll be taking a look at the different types of blockchain networks. This is the criteria that creates a big difference between two different kinds of blockchains, which is public and private. Right? So we'll take a look at that. Right. This, I have spared one entire slide on this, because always make sure you remember, blockchain networks, especially the public blockchain networks, they have all the data out in the open. They are public, but again, they are anonymous. Before blockchain came into existence, this combination, public but anonymous, this kind of combination I did not hear for any kind of technology, right? But with blockchain, we can see that everyone can see. Even we can see the first transaction that was done by Satoshi Nakamoto on the Bitcoin blockchain. We know that particular transaction was done by Satoshi Nakamoto. That's why we can relate the transaction with the creator. But every other transaction, millions of the transactions that have happened on the Bitcoin network or Ethereum network or any such public blockchain networks, we all know that they have happened. We can see how much Ether was transferred, how much Bitcoins were transferred. But then again, we have no clue that who is behind that particular address. Public but anonymous. That's all. Perfect. Any questions here? Because we are moving to another second section of our lecture. Any questions here? Would be happy to take. Please write in the chat. If not, I don't see any questions till now. If not, okay, no chat yet, so I'll move ahead. But in case you have any questions in between, please do write to me. Perfect. So what are the types of blockchain that we know? I wanted to cover this in a bit of detail, attacking certain concepts. So we have public blockchains. We all know examples: Bitcoin, Ethereum. So all these are examples of public blockchains. And essentially, any public blockchain is any blockchain where you have a blockchain explorer available for the use of the public. You can go to that blockchain explorer. If you haven't gone yet, you can try out the Bitcoin blockchain explorers, the Ethereum blockchain explorers, and you'll understand that what I'm talking about. If I have time at the end, I can do that as well for you on call live. So public blockchains are the ones which have their ledger completely open and all the transactions are visible on the network. Another characteristic of public blockchains is that you can join the network at your will. You can set up their own client on your particular computer, Mac, Windows, Linux, anything, and you can download the entire copy of the blockchain ledger that is there, and then you can start as well as participate in the network. You can start mining transactions if you have that kind of compute. And also you can start updating your ledger, and you can continue to go on like that. Those are public blockchain networks. Ledger is open, and also you can be a part of it without anyone's approval. Private, on the other hand, which is on the right side, private blockchains are very centralized, to be honest. They are not 100% decentralized. They are quite a lot centralized, but definitely they use blockchain technology, so they are in a very gray area. And what happens is that in private blockchains, you need permission to enter a particular blockchain network. Similarly, you need permission for a hybrid network as well. So these are the two networks where you need permission to enter the network. Additionally, what you have is when you're transferring data, there is one central authority which takes control of that, takes care of that entire blockchain network. That is why I'm saying that usually in this scenario, the blockchain network is a bit close to being centralized as opposed to being decentralized. So and it's a direct connection between all the nodes. If there are 1, 2, 4, 5, whatever nodes are there, there is one ledger. The consensus mechanism is controlled by the single entity, and all of that happens in a public network, private network. When we combine both of these, we get a particular blockchain network, which is a consortium blockchain network, or a hybrid blockchain network, or a permissioned blockchain network. You can call this by either of the names. There are very, very slight difference sometimes people make. But at this level, if you're learning it for the first time, you can consider all of these to be kinds of hybrid networks, where you're just combining methods and functions and characteristics from two different public and private blockchains. Right? I have an explanation which we'll cover. So public blockchains, you can see that they completely eradicate the middleman. When you're doing an Ethereum transaction, or when you are participating in the Ethereum mining, there is just zero middleman. It completely eradicates that concept, and hence the rates, the fee that you pay for anything in real life, I'm not just talking about between blockchains, but the fee that you pay to intermediaries in real life to get a job done, that goes off from the chart. Also, they are, again, we have discussed it so many times today, that they are public transactions and they are anonymous, but they are anonymous transactions. So this is something, but yeah, public, they are available on the ledger. One characteristic of public blockchains is that they are economically incentivized. What is that? Miners make sure that they take a look at, so they have an entire pool of transactions before they pick the transactions in the blockchain while mining, and they usually sort it based on the kind of transaction fee associated with every transaction. The more the merrier. Right? So for example, if you want your Bitcoin or Ethereum transaction to be pushed to the front of the queue, and you want many miners to pick them, TechnoSpark 3, I think you are trying to annotate something. Would you please not do that? All right, I have disabled annotation for others, but I don't know how to remove this. Okay, Mr. Coyote, is there something that we can do? I think this might create a bit of problem.
Okay, what is that?
Okay, I think I have an option. Clear all drawings. Yeah, all done. Cool. No problem. Yeah, I think someone by mistake, did some scribbling on my blockchains, right? So I'll move ahead. Now I have disabled it, so not a problem. So where was I? Yes. So the what public blockchains have the flow breaks. Okay. So miners are, when we were talking about miners, they usually rank, so they have a pool of transactions, as I said, and that is why I was telling that when you're doing an Ethereum or a Bitcoin transaction, TechnoSpark 3, I think you're on unmute. If there's a question, you can post it in the chat, please, or else we can take it up later. So yeah, so that is how these blockchains work. If you pay more transaction fee per transaction, there is a high chance that the miners in these networks will pick up your transaction faster than they would any other transaction. So they are incentivized. So this is one of the incentivization mechanisms, right? Incentive mechanisms that we are anyways going to cover a couple of points more on this. But then again, this is what incentives are. The miners are incentivized in value. This is value incentivization. That I will mine more transactions which are higher value, which have higher transactions fee associated with them. Also in public blockchains, the more number of nodes in that network, the more the merrier again here as well. So the more number of nodes, the stronger and the more secure this particular blockchain becomes. Currently, Bitcoin network itself has, I think, 20,000 plus nodes all over the world. What happens is that, see, why are they secure? Let's try to understand that. When we are talking about a blockchain network, there is an attack. I'm going a bit technical, but I think we can digest it easily. Won't go into much of detail. There is an attack called the 51% attack, which says that if more than 51% of the nodes in a network go malign, that network can be hacked. But this is a theoretical concept. Why? That is why blockchains are practically unhackable, which I shared a couple of slides earlier, that it is hack proof. But theoretically, this attack exists, and this attack can only happen when the number of nodes are less. For example, if I have a 10 node network, 51% and above would mean 6 nodes out of 10. It is fairly easy, not very easy, but fairly easy to talk between those 6 nodes and collude and make sure that they all 6 of them come together and do bad things. On the other hand, if you're talking about a network as large as Bitcoin, if you're talking about 20,000 full nodes running all across the world, 51% attack would mean 10,000 plus, 10,001 or so plus nodes would have to be bad. It is practically an impossible job for one node to go around the world talking to 10,001 different nodes and collude, and that to reach one financial benefit which not even be benefit to a lot of people. So that is why this is so secure that 51% attack cannot happen to a network like Ethereum or Bitcoin, because they have grown so big. So the more the network grows, it becomes impossible, practically impossible to break that network. That's why people don't believe private networks are very secure, because then again, there's two parties transacting privately. It is almost similar to being centralized in nature. However, one demerit of public blockchains is that the transactions per second, the throughput, you can say, the transactions per second is a huge bottleneck. Can someone write in the chat if you know that how much time, I'll move ahead, maybe I can tell the answer later. Can someone tell how much time it takes a Bitcoin transaction to be successful? And also how much time it takes an Ethereum transaction to be successful? Please write in the chat. Let's see that if the class is interactive. And I'll move ahead. I'll continue to explain. We'll take this up later otherwise. Please write in the chat if you know, or maybe a guess. I see one chat. I need more answers. Okay. Okay. I need more answers. Also for Ethereum. Any idea for Ethereum? Even blind guesses would do. I see Mr. Alexander. Yeah, I heard you. I heard you at the beginning. Of course, can I expect the answer from you? So right, 10 minutes for Bitcoin, 17 seconds for Ethereum. These are pretty standard that we know. And so 15 to 19 seconds you can say for Ethereum. But again, 15 to 19 seconds. You know what? I have one slide after some time which shows the difference between networks such as Bitcoin and Ethereum, and one network that we know so popular across the world, which is the Visa network. We'll take a look at the transaction per second throughput difference between these two networks, and then we'll discuss more about this maybe. I see more answers, but yeah. And Mr. Alexander writes that it's 0.2 seconds for free turn. So you have the answer there, and that is why all of that in the first slide that I showed. You have great opportunity to go for ton, right? So perfect. Perfect. So that is something. Please look into the chat if you haven't yet, everyone. Perfect. Thank you, Mr. Alexander. Thanks a lot. So yeah. So going ahead, let's take a look at. So transactions per second is a bottleneck in public blockchains. In private blockchains, that's not a problem. We have high throughput because the mining does not have to happen in that fashion. Is the basic form of a blockchain. Very limited participants, and within them the transactions per second is very high, and that is why it is similar to centralized systems. It allows high privacy of data because you do not share the data on a public ledger, but it is very less secure as it is usually controlled by a single entity. It again kind of comes back to that JP Morgan bank example that we are running a private blockchain. It is as good as, almost, not same, because it's blockchain technology at the end, but it's as good as using an RDBMS. So that is one concept I wanted to share. So beware when you're working on private blockchains. I am personally also, I'm not very sure how beneficial private blockchains would be to you. So make sure that you are very sure about the use case you want to achieve using private blockchains. On the other hand, when we are talking about consortium blockchains, this is the best one that you should pay most attention to. Public blockchains, you already know. Bitcoin, Ethereum, so familiar. Consortium blockchains, I have seen personally that people are not very aware of, especially people who are not in the industry yet. Consortium blockchains are semi-decentralized. They are very much decentralized, to be honest. Also, they are very secure. They are comparatively way more secure than any other blockchain networks, and also they are very well suited for organizations that want to run certain use cases on the network, on the blockchain network, right? So if you take a look at a few of the characteristics, they definitely have the characteristics of a decentralized network, such as, again, backed, immutable ledger, transparent only among the participants of the consortium network. It is not open to the public. That is how it differs from a public network, but also it is very close to a private network, but not a private network. That is where the value comes in. So for example, I can tell you that we are a consortium network, consortium blockchain. We use Quorum blockchain, which is built by JP Morgan, now given to now acquired by ConsenSys. We all know ConsenSys is behind Ethereum as well. ConsenSys' founder is behind Ethereum, Ethereum's founder as well. So good hands. And so that is a permissioned network. Do take a look. Quorum blockchain. So all these are examples of permission blockchains, and also they have a very good and important feature which we is very beneficial for us and similar use cases. When you have multiple stakeholders on a blockchain network, for example, you have banks, we have banks, we have warehouses, we have farmers, traders, we have then collateral managers. Every bank would not want that all of the transactions to be visible to any other bank on the network. So we have 5 banks on the network. Each bank will only want that their data should be visible to themselves and the warehouse that they're dealing with, right? And also the customer that they're dealing with, but not with any other bank, right? That is one feature that is not available on the public blockchains, which is what private blockchains brings to the table. They have, especially in networks like technologies like Quorum, they have something called private transactions, where while doing the transaction, you can designate the particular node to whom the transaction is going to be visible. When that happens, only those 2 nodes, say for example Bank A and Warehouse A, only those 2 nodes are the ones who are going to be able to take a look at that, what the transaction is, who the transaction was done on, how much is the loan amount, how much is the deposit amount, and all of that. On the other hand, there may be 10 different nodes in the network. They all will only see, because it's a ledger shared by every node. They have to keep a copy of that node. That is what blockchain is all about. So they will all see that Bank A did a transaction with Warehouse A. They will know about the transaction, but they will not know what the transaction is, how much was the transaction for, what constituted the transactions. So that is very important. Make sure that, I personally believe that you will find most use cases in consortium blockchains. Especially in the industry, if you're going for that. All right. Taking a step further, so any questions, again, I'm reminding you, please write in the chat, and I'll immediately take it up. We are well on time, and I think we can, we are not well on time. I see we have 40 minutes or so remaining. I'm sorry. So I'll go a bit fast, but you can write the questions, please. Or else I'll keep the last 10 minutes for questions anyways. So enterprise blockchain advantage, if you're talking about, this is, I just wanted to take a step further in helping you understand, especially about consortium blockchains and what kind of advantage that they bring. Consider this to be a part of types of blockchain and how to go about building use cases for them. So in consortium blockchains, access privileges, as I just said some time back, access privileges plays a big role. You can exactly designate which node writes and reads what kind of transactions. For example, in our case, we know we have given particular rights to the banks and a separate set of rights to the warehouses. Warehouses cannot do loan transactions, right? Because that's the characteristic of the bank. On the other hand, the banks cannot do the characteristics of the warehouses. So on and so forth. So we have very specific characterization of what kind of role a particular node may play. This is only available in permissioned kind of blockchains. You can designate these roles to the participants. Talking about visibility and privacy, as I said, permission network blockchains such as Quorum allow for designation of the transaction level privacy, right? As I said, every transaction we can designate. If it's between bank A and bank B, all of this can be designated that who are the recipients of that particular transaction. That is the kind of visibility and privacy which is unheard of in any public blockchain. That is not possible there because everything is public again. No lock on that. Also in private blockchains, this kind of visibility and privacy is not there. Privacy is there in extreme amounts in private blockchains, but in case of visibility, that is not clearly defined. Data and transaction storage. In consortium blockchains, you can very well, this you can do in private blockchains as well, to be honest. But yeah, most use case in consortium, so I'm discussing about consortium. The data and the storage of transactions, you can very well segregate, you can designate places and you can store them on the blockchain network. You can decide to store the transactions of the data on chain or off chain. Mostly people store all transactions on the blockchain and any associated data on off chain solutions such as a MongoDB or something like that. And then you couple and you show it to the customer. That is one benefit that you get with almost both the kinds of blockchains, which of course you can use in consortium as well. And execution and mining, this point again goes a bit close to the incentive mechanisms in consortium blockchains, which we'll take a look at. So in this scenario, right, the mining part of the blockchain network of the blocks can be given to certain designated nodes. We can make them leaders and they can be only ones who are signing the particular transactions, right? So they are the ones. This might go a bit complex, but I'll try to make it as simple as possible. But once you do it via your hands, it becomes very clear, to be honest. And I'm always available there. If you ever try these things out and you want to reach out anyone, please make sure you do. So when you are designating a particular bank, say a bank node, we are taking an example of a bank node, that bank node will be able to sign all the transactions which are lending transactions. That is how you are enabling execution in the platform. On the other hand, when we are talking about mining, the incentivization, you can this is pretty much covered using a very neutral approach. Certain you can say certain consensus mechanisms such as Raft, which we use in Quorum blockchain, and similarly IBFT. All of these are PBFT, IBFT. All of these are consensus mechanisms that consortium blockchains are very frequently using in today's world. And they have a very neutral way of mining the blockchains, mining the blocks. In Raft, one leader is chosen at random, and then again the leader mines the block, goes back, someone else becomes a leader, and so on. It does not consume resources like proof of work does, nor like Ethereum's proof of stake does, or again Ethereum going to proof of stake now. So none of it is common here. It's a very neutral kind of a consensus mechanism, just to make sure the blockchain network goes on. Okay, again this is talking further about incentive mechanisms, and as I said that we'll be taking a look at 2 attacks on these kind of mechanisms as well. Let me check the chat once if there is any question. No questions yet. Okay, please do write, otherwise I would believe that my lecture is not very clear. Then I'll try to make it better anyhow, right? Please, there is any problem, write to me in the chat. All right, otherwise we will be done in the next 20 minutes and then 10 minutes for questions and we should be done. So incentive mechanisms, let's take a look at that. What happens when miners become a part of a blockchain network? When a particular miner is taking a host of transactions and considering it in a blockchain, in a block, and he wants it to be mined, there is one aspect that miners think of, which is the value gain. As I said earlier, and right now also, every Bitcoin miner is behind this value gain only, right? Because they get 6.25 Bitcoins after mining every block. That mining a block is definitely has become harder and harder, but then again there have been so great devices like ASICs and all, which continue to provide great value to the miners, right? So this is one aspect. One incentive mechanism is always to generate the value from mining the particular blocks in that blockchain network, and in return getting the native currency of the blockchain, that particular blockchain network. For example, Bitcoin in case of Bitcoin network, Ether in case of Ethereum network, and so on. That is one value gain, and this is usually applicable in public blockchains. Please make that sure. This is barely available in private or consortium blockchains. I have a chat. Claire has said, kindly explain who miners are and what they do in the blockchain context. Perfect. I'm sorry if I've gone a bit advanced in this without explaining that mining concept. Who miners are basically, some of you might be knowing, but it's best to clear it out. I should have done that myself. I'm sorry. What miners do is basically they just keep the blockchain intact by making sure that we are using cryptographic security, you can say, a security mechanism, which adds to the security of the blockchain network. Let's take an example and understand this, because all blockchain networks are currently doing mining in a different fashion. There are many consensus mechanisms. I have not included that in today's presentation, but I usually deliver those because they are very important. But I wanted to keep this a less technical. So there are different kinds of consensus mechanisms. Let's take one very popular example, which is used by Bitcoin, which is proof of work. What happens in proof of work is that miners who are mining the blockchain network, again, what is mining? Nothing. It is simply picking up a set of transactions, considering it in a block, and then the miner is every miner on the network is posed with a particular cryptographic problem. The only way to find an answer to that, this is all I'm talking about proof of work. The only way to find an answer to that cryptographic problem is by hit and trial. No other way. You, in fact, in the case of proof of work, you already have the answer to the crypto problem in front of you, but you cannot do anything because you cannot decrypt. These are secured by, these are encrypted by, for example, Bitcoin uses SHA-256 hashing algorithm. Bitcoin does it twice. Bitcoin first takes the set of transactions, does a hashing of with a SHA-256, then whatever they hash they get, they again hash it via SHA-256. It becomes very hard to crack that kind of a thing, and that is why no one has done yet. So that is how the headers in a Bitcoin block are formed. So when we are talking about such cryptographic measures, the only way for miners to find a solution to the problem is by hit and trial. That is why the devices used for mining, say, Bitcoin blocks in proof of work, their only job is to hit and try millions of transactions, millions of trials per second to reach at a conclusion. And whoever out of 10 different miners, for example, whoever is the first person to arrive at the solution which is given there, which in the Bitcoin case, again, I'm trying not to go very technical, just a hint, you can learn more about it on the internet. In the Bitcoin's case, it is basically, finding that answer which has a set of trailing 6 or 5 or 7 zeros at the leading 5 or 6 or 7 zeros at the start of the final hash. That is when you know that you found the answer. So, but then again, huge complex cryptographic calculations go behind finding this answer. When you do, whoever is the first miner to do so, the network accepts him as the miner. The block of transactions that particular miner considered as a block goes and gets attached to the Bitcoin blockchain. And you can say, so what happens is that there is, I'm going a bit technical, there is a pool of transactions that whenever say I send one Bitcoin to Mr. Coyote, that transaction will go on the Bitcoin on the pool, which is called mempool. It is called mempool, technically called mempool. From that mempool, any next miner will pick up n number of transactions, say 100, say 50, say 25, say 10, any number of transactions he wants, the miner wants. After that, he would know what problem to solve. So for example, if my transaction of one Bitcoin to Mr. Coyote can be a part of 7 out of 10, 7 different blocks which are being mined currently, right? 7 different miners took the top 50 transactions from the pool. So my transaction was there in the top 50 transactions. So it got picked up by every miner. But whoever will be the first miner to find the answer first, whose block will be considered, that block of transactions, it could be any n number of transactions, that will be attached to the Bitcoin blockchain eventually. So if my transaction was picked up by that particular miner, it will be confirmed in the next block, whenever that next block comes into picture. So that is, and again, if you remember, I said based on incentive mechanisms, that is where incentivization comes in. The choice of the transactions that a miner picks is completely based on the miner's availability of resources, as well as what are the transaction fee attached with every transaction. That is what lures the miners into picking up your particular transaction if you're paying more than anyone else is. Because once you mine a transaction, there are two ways of incentivization. Please remember this. Number one, For in the case of Bitcoin, you get 6.25 Bitcoins. As a miner, you get 6.25 Bitcoins on mining every one block. Just some time back, until in 2020, it was 12.5 Bitcoins. It gets halved after every set of number of blocks. It just got halved to 6.25 Bitcoins now. So what happens is, apart from this 6.25 Bitcoins of the native currency that they get, in addition to this, the miners pocket all the transaction fees that are associated with every transaction that they picked in their block. That is the reason why miners usually prefer picking the transactions with the highest transaction fee attached with them. That's basically it. So that's how mining works. And the proof of work consensus mechanism makes you do work to find a particular answer, which is the work. The proof of work is the work that you solved using millions of trials and errors. You solved that particular question, you spent a lot of electricity, a lot of resources, and a lot of time on it, and eventually you found the answer. This shows a proof of work that no collusion had happened, no bad actions had happened. It is all clear. You really did the work and you put the miner block in the place. That is one. That is how mining works. I hope I've answered your question clear, and also I hope that this was valuable information, because it is one of the basic concepts of blockchain that we should know. So that is one kind of incentive. I see a chat. I see that Shyamaka has, I hope I'm pronouncing the name correctly. How can somebody be a miner, and is it possible for a transaction on public blockchain never to be approved? Very less chance, to be honest, because there is a set. So first of all, how can somebody be a miner? You can join a network. You can join a network like Bitcoin. You can bring in your. There was a time when Bitcoin could be mined using your own MacBook computer, right? Your laptop is sufficient. Now even big mining farms exist, and the you can say the hash rate has gone so high, which has made it so difficult to mine bitcoins, that people with huge ASICs, which are ASIC is basically like this. It is application specific integrated circuits. These are computers, these are machines that are made specifically to mine such transactions. Then there are various kinds of ASICs, right? So whoever is into Bitcoin mining, they usually find the perfect device, perfect machine. They attach it to the Bitcoin network, they download the Bitcoin CLI, and then they participate as a miner. That is how you go about being a miner. For every other network, there is a different process, easily available, because public blockchains want you to be miners on their network, right? They want more and more miners, right? So it is readily available information. And apart from that, into your second question, that on public blockchain never to be approved, very less chance, because always, say for example, Ethereum. I'm sorry if I'm going a bit fast. I have less time, that's why maybe. So when we are talking about Ethereum, say, there is a gas fee attached with every transaction, right? So there is a minimum gas fee that the network defines you to pay. You cannot pay below that, and so that mining fee is sufficient for the miners to pick up your transactions. So even if not in the next block, but maybe in the second block or third block or fourth block, people will eventually pick your transaction, because no one wants to leave out even pennies on the dollar, right? So that is why there is very less chance. If it is a good network, if it is a huge network, more the number of nodes, the merrier, you remember. So if it is a good large network, there is almost is practically impossible that your transaction will be there forever. But yeah, one thing, I have not put it on my slide, but I usually deliver that. One use case was, please take a look at CryptoKitties. You must have seen CryptoKitties being very famous back in 2018 or 17. When that CryptoKitty launched on the Ethereum network and then suddenly became famous, what happened was that it choked the entire network. For that, during that duration, I think 20 or 23,000, or I am not remembering the number now, but a huge number of thousands of transactions were pending at that time for a long time, right? And it had completely choked the network, Ethereum network. That was the longest time, maybe some transactions, and I was part of that time. I remember doing a transaction at that time, and it did not get approved for maybe quite a few hours, to be honest. That does not happen in real life in general now. Right, that was one case. You can take a look, out of scope of this lecture, but you can take a look what happened when CryptoKitty got launched and got really hyped out. All right, going ahead quickly. I hope I've answered your question, Chiamaka. I think, yeah, that's the name, right? I checked. I hope it's pronounced properly as well. Another type of incentive mechanism is that of a TAT gain. This is not at all specific to public blockchains, does not happen there, very uncommon. but very, very common in consortium blockchains. See, in consortium blockchains, the miners or the nodes don't have any other incentive apart from certain business incentives, right? So what are the kinds of business incentives? Okay, thanks a lot, Shyamaka. Thanks a lot. Perfect. So in that gain, it is when, so for example, our blockchain network has banks and warehouses and nodes and us as nodes, right? We are not giving out bitcoins, handing out bitcoins to mine the transactions, right? So the incentivization mechanism in such blockchains, consortium blockchains, differs greatly. So here, all the nodes want one thing. So in our case, for example, all the nodes, even the warehouse, us as well as the banks, they need one thing, that the farmer gets the loan as fast and as quickly as possible. So that is why they are a part of our blockchain network and our business network as well, because they want a seamless lending to happen to the farmer, because that benefits the entire business altogether. So that is the kind of incentive. It might not sound like a direct incentive that, okay, why here I'm getting 6.25 bitcoins, here I'm just getting what, a TAT gain. TAT is basically, I'm sorry if I've not written it down, it is turnaround time for people who don't know. So turnaround time is the time which it takes for you to come back to me with a service. So like for us, it is loans to farmers. So if we take 10 days, that is our TAT. If we take 10 minutes, that is our TAT. So in our industry, in our segment where we just came out with a blockchain network, previously when we were not there, this loan used to take 7, 8 or 10 days. Now on our blockchain network, because all banks and warehouses are on the same platform, it takes less than 10 minutes or few minutes, 20 minutes or so to get the loan done. That is one gain that currently all our stakeholders and nodes get from the network. That these are two very diverse kinds of incentivization mechanisms that are there. In addition to that, I created a division. I wanted to talk about two kinds of issues that can happen regarding incentive mechanisms. Manipulating consensus. You know what can happen when, for example, in our node itself or in a private network, for example, in a consortium network, it happens rarely. In a private network, what happens if, not in a private network, I'm very sorry, in a consortium network, what it can happen is that if one of our banks wants to do some collusion and wants to delay the transactions in happening, what will happen is that other banks will also not be able to process the loans. That is the kind of business game a node might play. It is very unlikely, but it is theoretically possible. So that is one business issue that can happen, especially in consortium nodes, that if a node particularly blocks the transactions from happening in some fashion, by either by not mining their own block or not allowing transactions to happen via their nodes or something of that nature, the network will suffer as a whole. That is one problem. On the other hand, in certain cases, in certain blockchains, what nodes certain participants can do is mess with the oracles. I'll tell you in one line to cover it quickly what oracles are. Just like in everyday systems.
Here, I've told her.
Yeah, hi.
The stamp, give me the stamp.
Hi, Miss Lorraine. Is there? You're unmuted, Miss Lorraine. Is there a question? If it's fine,
there's a discussion around Kiambu University to discuss it on Thursday.
Mr. Kaude, I think you'll have to step in if you have the option to unmute Mr. Lorraine.
It should not be true. That is because you agree with me. Would you approve?
Okay, we'll wait for Mr. Coyote to maybe. Miss Lorraine, if you're there, could you please unmute your mic? You've just sent it to me, I think. Okay, perfect. Miss Lorraine has just. Thank you so much, Miss Lorraine. So I'll quickly continue. So oracles, in one line I was saying, oracles are such external data sources which provide information, external information, say for example climate, weather conditions, or the stock prices, right? Prices of a stock in any of the stock markets, or maybe any such kind of external data to any blockchain network. Blockchain networks can't just communicate with external APIs. They have to have these kinds of oracles in between to get the external data. So if someone messes with that oracle, then the data that a blockchain network will get will be bad. It will be maligned. In that scenario, the network or the smart contract especially will be acting on that wrong data, which might create a bad business proposition. Again, another kind of attack which happens in incentivized mechanisms where people want to collude and want to take unfair advantage of any role that they play. Say for example, a bank has been given the role of leading all the transactions, right? Of signing all the transactions, and then the bank node decides that okay, I'll stop signing transactions now, so that any other bank can also not sign transactions. That is bad behavior, and that can create some problems. It is unlikely, it is theoretically very unlikely to happen, because you have every node. It's not a public blockchain, it's a consortium blockchain. You know everyone, you won't let that happen, but then again theoretically these are possible, so always good to know, right? So this was incentive mechanisms. I'm done with this section. We'll now quickly take 15 minutes, take a look at a few use cases, and then we'll be done with it. Any questions now? Please, you may put in the chat, or I'll move with this last section of the lecture. Okay, I don't see a chat, then I'll move ahead. If there is anything, you can just write to me again. Perfect. So let's take a look at blockchain and innovation and certain enterprise applications, very good enterprise applications that I personally feel very likely to be successful on blockchain networks. Two of them by very big companies, one of them by my own company, and we'll take a look at that. Before that, as I promised just some time back, I wanted to show, because this is a part of the maybe integration part of this. This is not a direct use case, but definitely a future use case. Let us see why you cannot buy, even till now, you cannot buy coffee at a Starbucks near you by paying Bitcoins there. Let me see. So sometime back, Mr. Alexander said that for Bitcoin it is up to 10 minutes. For Ethereum it is 15 or 19 or 17 seconds in between that. Did you know that Visa's transactions per second, the throughput is 1,736 transactions per second? That is the maximum that the Visa network has faced. And this was a day, I remember reading it online on a news piece, that this was a day when they received 150 million transactions across the world in one single day. That was the day when they received the highest transaction per second throughput. And they have promised up to 50, they have their integrations and they have their infrastructure to handle up to 56,000 transactions per second, which is so far away. It is 50 times what we are seeing currently to max out. On the other hand, Bitcoin is 4.6 transactions per second. Huge gap. Another problem is that when you're paying by Bitcoin, you are even not sure that it will happen in 10 minutes, right? It might sometimes, one block creation might even take more than 10 minutes, as we were seeing at that number. It can, you can go, I don't think time will be there. Otherwise, you can go and take a look at any of the blockchain explorers and see when was the last block created. See the difference of time between all those blockchains or all those blocks on the Bitcoin network. Some block could be created between 10 minutes. Some could be created for after 20-24 minutes, and so on. So this doubtful nature of the transactions makes it impossible for your regular Starbucks to start accepting Bitcoin payments. As you can see, Visa has 380 times Bitcoin's throughput. So whenever the number of transactions grows, it would happen like 100 people are standing in line in that particular Starbucks who are trying to pay via Bitcoin, because none of them knows. Not even the Starbucks barista, not even anyone in the line, none of them know that when a particular person's transaction exactly will be processed. It could be like within 10 minutes, it could be 50 minutes. Go and see a blockchain explorer, you'll see this difference live. All of it is public data. There has been no technology in the past which has been such public in nature. You can go and see everything. You can not only see the first transaction that Satoshi Nakamoto did, you can also see, just do a transaction and see your transaction there as well on the public blockchain network. Very important here. You do take a look, and I am always available to help you out, right? So that is why I just said that you cannot, because you do not know that when your coffee would arrive or when your payment would go through to Starbucks, because it can take 10 minutes, it can take 40 minutes. It is uncertainty that creates the problem. If you knew that it is for sure 10 minutes, you would have still waited, but you do not know exactly, right? So that is the nature of this issue. Quick roundup before we take a look at those three resources, those three use cases. We have very less time. I'm sorry if I'm going a bit fast. There is so much to share. Blockchain is so vast, and I'm so passionate in sharing all of this with you. I sometimes go very, very fast. I'm sorry about that. So you can check on the screen. You can read it out as well. That what Visa has to do is just a payment infrastructure network. What Visa has to do is payment transactions processing, and that is 1:1. I go online, I use my card on a Visa enabled website, and I get my payment done, and that is 1:1. My bank is taking care of that via the Visa network, and I am the only person. On the other hand, and that is one ledger, because these are centralized systems, there is one ledger where they need to write this transaction down, and at the end of the day they reconcile it. On the other hand, Bitcoin has to tell the same transaction that I paid 1 Bitcoins to Mr. Coyote to maybe 10,000, 15,000, 20,000 different nodes who are keeping a track of that Bitcoin ledger. Geographic problems aside, this is a humongous task in real time to communicate with everyone that this transaction has happened. Please update your ledgers respectively. Huge problem, right? On the other hand, Ethereum network now, because it provides a second generation network, there are different generations of network. This is a second generation network. So on the other hand, what happens eventually is that Ethereum gives you the ability to build smart contracts as well, right? What happens in the case of smart contracts is there's a lot of data to be processed. There's real-time data, and then smart contracts are pieces of code which act on that real-time data and do certain actions just like normal code, but these run on blockchain. So Ethereum network is not only having to provide an infrastructure for the Ether transactions, but also for the immense nature of the smart contracts that are being run by every other organization on the Ethereum blockchain. Again, huge data to be transferred all through the ledgers in real time, right? Very different from what Visa has to do. That is why things are so much developing. Before proceeding, next is use case. Before proceeding to the use cases, I would like to cover in 1 minute or 2 minutes, I would like to cover the generations of blockchain. I had skipped it out because of lack of time, as we can see, but I believe it is very important to just tell you about the generations of blockchain if you already don't know. There are currently so first generation of blockchain came with Bitcoin, which was just a transaction based, currency based blockchain in nature. That's all that Bitcoin does. Bitcoin allows you to do Bitcoin transactions, and that is all. The second generation of blockchain came with Ethereum at its centerpiece, and Ethereum allows you to not only do transactions on the network, but also write code, deploy those code on the Ethereum network, and they run on real-time data. This is a very new, that is why people call Ethereum to be the world computer, right? Because this is the new form of functionality that Ethereum brought into the world of blockchain. Second generation, that is the second generation, and that is the generation currently most stable at the moment. Third generation of blockchains take care of features such as sharding. What is sharding? People who don't know what is sharding, sharding is basically dividing the data into different areas so that one blockchain network or in database, sharding means that one database does not get so heavy that it's difficult to work with. So in blockchains, they divide the data into maybe separate places. Then there's sharding, then there's interchain connectivity, right? Cross-chain connectivity, you can say that is talking between two different chains. There is side chain functionality, another feature of third generation blockchains. Side chain functionality is there is one main blockchain network, and there are side chains of that same network where you use those side chains for certain kinds of activities, such as for sharding the data between those two chains and keeping all the unimportant pieces of data in the side chain and only the important transaction level data on the main chain. These are all methods to increase the throughput of blockchain networks, because people saw that first and second generation blockchains were not able to be very fast, as you can see on the screen itself right now. So that is what third generation blockchains were working on. They have been very successful till now. People have received thousands of transactions per second on the blockchain networks as well. So very close to Visa, you can say, or such networks. But they are not into very much of mainstream production right now. See, even free turn, you can see it's 0.2 seconds. So these kind of transaction throughputs can really be used in real-time scenarios. So if you want to pay for your coffee at Starbucks, you can use free turn if they accept, right? If they want to, they can, because you'll know that within like 0.2 seconds or within a second, you'll have that block ready. The block will go into the free turn blockchain, and I don't know the technical nature of the free turn blockchain. Maybe Mr. Alexander would be better placed to talk about that. But then again, with this kind of block time, you would know that it is moments before which your coffee transaction will go through, unlike in Bitcoin or Ethereum or such blockchains, right? All right. So and going ahead, so that is third generation, and then fourth generation are people still experimenting. Let's not go into that. All right. Any questions, please write in the chat. I am so Mr. Coyote, how much time do we have practically? I have 3 use cases to share. How much time do you have? I'll go ahead. If you could just let me know about the time, then I'll tune it accordingly. So, but let's not spend any more time. So, one use case that I wanted to share with you to give you a great idea of how blockchain works is when IBM. Let's take a quick look at it. You can even read the text on the slide to go quickly. IBM came out with this food trust blockchain that they built, and they put an entire supply chain on the blockchain. So currently we know, there are people, so many people dealing with supply chain management issues. Blockchain solves many of them. So what IBM did was they went all with blockchain and IoT information on their food trust blockchain, and with that they tried to provide the end-to-end information of a supply chain to the consumers, right from where that particular commodity was grown, sown, harvested, where which warehouse it went to, which factories it went to, when it got processed, which distributors it went to, and eventually when it got delivered to you. And then you can scan and you can see all the data in front of you as a consumer as well. That is one way to create less friction and maybe a more global approach. And IBM being a very global company with great use cases, they carried this out very successfully, right? Another use case, I could have delved deeper into this. We are lack on time, but you can go ahead and you can search for it, and you'll find an entire white paper on this, to be honest. Big use case, this is one use case that I liked a lot, because previous to this startup, I was in an insurance aggregator, which is India's biggest again. I was there. And insurance using blockchain, they don't use insurance on blockchain, but many have tried this out. And Accenture did this particular use case research that insurers can really put insurance and claims on the blockchain, and you can read the numbers. They can prevent, I mean, they can save between 99 to 277 million dollars annually just by doing claims and insurance on blockchain. Insurance domain is definitely very complex in nature, and people have usually faced a lot of problems. And with the use of, so Accenture wanted to has done an entire case study on this, and they wanted to bring together IoT sensors, then oracles which take data from the outside world, and then put all of that into blockchain to help process claims at a much faster rate. And this brings in a lot of savings to the insurance companies as well, which is the numbers that you can see on the screen. Big use case. Again, a big company, Accenture, you can read about it. Very quickly going through what we have done. Again, I would have not put this if we wouldn't have done such big work in India itself. This is not an advertisement, to be honest. There are huge frauds that have happened. $3 billion in Qingdao scandal happened in warehouse receipt finance segment, again a fintech segment, right? And to be honest, these had names such as Standard Chartered, Citibank, all big names who were hit by this fraud. Then in India, it was $1 million NACL scam back in 2015 or 16 or so. So using blockchain and IoT, in this particular segment, we are trying to eradicate a lot of frauds which are faced by big and major banks, not only in India, it is across the world. Qingdao scandal was in China, not in India. And big names have faced this problem across the world. That is why the state governments in India and also banks, major banks, are very happy to work with us, because this is a major problem that they've faced for decades now. And with that, you can see on the screen, with that we have actually implemented this one. That is why we tell that it's the largest agri fintech blockchain in India, because we are implemented across 1400 warehouses. And these are not people who know blockchain or are computer science engineers. These are very normal people who are running warehouses, but they are happy to use this platform because it is not tough. It is not at all tough. Just because it is blockchain, it is not tough, right? And within 8 months, we went to 1400 warehouses across 5 states of the country. And the Indian government is also happy to see this kind of an implementation in blockchain being done at such a massive scale, and we are only growing. And in India, unlike in US, we do not have 4,000, 5,000 banks. We have very few limited 18, 20 or 25, 27 banks in total. Out of that, 5 banks are already on our 5 lenders and banks are already in discussions on our platform already. So that is something we've done, and we've done more than $1 million of loans within the last few months, and we have over $500 million of commodities tokenized on our platform, more than $500 million of rice, grain, and cereals and pulses and everything that have been stored in our warehouses, that have been tokenized and put on the blockchain network. That is why it is one of the biggest in the country. That's all. I am done. If you have any questions, you can write to me. I'm on LinkedIn, I'm on email. WhatsApp is the best way to reach out. It is on the screen, and happy to help. I'm doing a lot of work in blockchain, and if anyone else is doing as well, happy to collaborate. Any questions? Otherwise, I see that we are almost 1 hour 30 minutes, so I believe I've ended at a good time, Mr. Kayode. I hope I didn't go very fast. Please, questions. I'm expecting questions, really. Any use case questions, any technical questions, anything. Please do let me know.
Alex, thank you very much. This has been a very insightful discussion so far. I mean, it's so much rich and the content has been deeply vast. I mean, we'd like to thank you for coming around today to tell us about blockchain, the background, and also even educating us much more further than we even plan to even learn from you. And I'm sure the crew here today have some questions. I don't know if you have some questions. We can actually drop the question in the chat box.
Yeah, please do.
Or by raising your hand, we can also.
Yeah, you can unmute and you can ask.
Thank you very much. Somebody's saying.
Yeah. One request before
Yes,
before I take a question. One request. So please, I've just given out a link on the chat. This is a really 10 seconds feedback. Anonymous. Don't have to put your name or phone number or anything. Just you need to write how this session was, so that I can. I've taught more than 4,000, 5,000 students and faculties, right? So this is a way I improve my next lectures. If you just give me feedback on this one. One feedback could be that I went very fast, something that I've received, I've tried changing. Please do fill that feedback form. Just click on it, it'll take you 7, 8 or 10 seconds to fill it, promise. Yes, please, any questions, anyone, please unmute and you can tell. Any questions? Any questions? Claire, Shyamaka, any questions? Mr. Mutemi, Joseph, you came up with that 17 seconds for Ethereum. Any question? Titose, Olive, I'm taking out names. Any questions? I'm happy to answer. I mean, from use cases, I'm expecting some questions. If not, then we can be happy to drop out, Mr. Kayode. Okay, thank you so much. No questions. Thanks a lot, Joseph. Glad to hear. Mr. Mutemi, that was amazing for me to hear. Please do click on that feedback and leave it in that feedback as well, so that I always remember it when I read it and I give the next presentation somewhere. Or maybe with Africa Blockchain Institute if that happens again. And so please let me know in the feedback. Yes. Anything else? Otherwise, Mr. Kayode, we can drop off. I don't think we have questions. I took quite a lot of questions in between as well. So maybe people are up with their questions.
Okay. Thank you very much again. So you can still hang around because we are now proceeding to the core of today's program, which is the from the Ton Lab. We have the lead engineer, the CTOs, and also we have the co-founder here to bring up to speed happenings at the Ton Lab and how we could get the student to build the product on the Ton Lab. So I want to hand over to Mr. Alex Randa to lead us on the Ton Lab and also introducing the rest of the team at the Ton Lab here today. I know we have Mr. Ron and also Mija and Pavel. Any of you guys, I'm so glad enough to introduce yourself so that we can get this program going. Thank you very much.
Perfect.
Yoda, thank you very much. Without kind of saying more, I would like to hand over to Mitya Goroshevsky, who is co-founder and CTO of Ton Labs. Mitya, great to have you.
Yeah, I'm trying to.
Hi everyone. Can you give me the screen, please?
Yeah, I'm trying to, Mija, I'm trying to escape out of this. 1 second, please. Give me one second, 30 seconds.
No problem.
Something is hanged.
So let's dive into a little bit more kind of technical, and I will just give a short presentation on the capabilities of the Freeton blockchain and how it's all structured and what kind of tools it has. And you can, I planned it like for really short, and then I will hand over to Katya and Boris